Hello, in this video I'll try to explain the interfacing of relay and buzzer to LPC1768 microcontroller to control the status of relay and buzzer using switch. Let us look into the algorithm. So using schematic diagram you have to identify the required pins and you have to configure those pins as general purpose input output pin without affecting the functions of the other pin using pin selection register. It's very important. Then set the direction of the pin using FIO DAR register. That direction may be input direction or output direction. Write the value to the pin using FIO set or FIO clear register. If you want to send the information, or if a microcontroller want to send the information to the outside world, then you have to use FIO set or FIO clear register to write the value, and read the value from the pin using FIO pin register. Let us consider the schematic pertaining to buzzer and relay. So that buzzer essentially consists two terminal. So you have to give the supply. So one of the terminal must be connected to supply voltage, other terminal must be grounded. Then this buzzer will generate a sound. So in this circuit, so one of the terminal of the buzzer is connected to plus 5 volt, whereas other terminal is connected to the collector end of the transistor, and the base of the transistor is connected to in 8, okay, input terminal 8. So here whenever the base of this transistor is 1, the transistor will pull to 0, so the other terminal of the buzzer will become 0, circuit will close and buzzer will on, so it makes a sound. So if you want to switch on the buzzer, then essentially the in 8 terminal should send logic 1 to the base of the transistor. So you have to identify the in 8 terminal connected to which pin of the microcontroller. So you look into that. This buzzer is connected to connector A5. So connector A5 in 8 corresponds to 8th pin. So you have to look into the corresponding connector A at the microcontroller side. So the pin number 8 of connector A is connected to 11th pin of port 0. Okay. So if you want to control the buzzer, then you have to select 11th pin of port 0. In this schematic, the 11th pin of port 0 is connected to input terminal 8, so which is in turn controls the state of the buzzer. If you send logic 1 via 11th pin of port 0, buzzer will be on. If you send logic 0 via 11th pin of port 0, buzzer will be off. Okay, this is about controlling the buzzer. So you got one pin, that is 11th pin of port 0. Now consider the schematic of relay. The relay is an electromagnetic switch. Here we are considering dual pole dual throw relay. That means with the help of single coil, we can control two poles. Two poles of the relay can be controlled by single coil. Generally, the switch position of the relay is initially connected to normally open terminal, and when the coil get energized, then the switch will change the position from normally open terminal to normally closed terminal. The coil will get energized when the proper supply is applied. In this case, one end of the coil is connected to plus 5, whereas the other end of the coil connected to a terminal called REL, that is relay terminal. Whenever this relay terminal becomes 0, the coil will get energized. The switch will change the position from normally open terminal to normally closed terminal. In that case, a supply will be passed via LED and the LED become on. Okay, so when relay is on, LED is on, and when relay is off, LED is off. To switch on the relay, your microcontroller should send logic 0 to this relay terminal. But the thing is, your microcontroller cannot drive the high load devices like relay, stepper motor and DC motor. Therefore, essentially there is a requirement of a driver. Here we are using ULN2803 as a relay driver. So this is an array of transistor. This is a high voltage, high current driver. So which consists 8 inputs as well as 8 output. Generally, the output is inverted version of the input. That means if you apply logic 1 at the input side, output will create a ground path for the load circuit. Okay, that means if input 7 terminal corresponds to the third pin, that is input 3 of the driver is 1, then the corresponding output will become 0. So which in turn creates a ground path for a loading device. Okay, so here our relay terminal is connected to out 4 of the driver. The out 4 corresponds to in 4 of the driver, that in turn is connected to in 5 terminal of the connector. Now in connector A5, in 5 terminal corresponds to 5th pin of the connector, and at the microcontroller side 5th pin of the connector corresponds to 8th pin of port 0. That means the port 0th 8th pin is used to control the relay. Okay, P0.8 is to control the relay. So whenever your microcontroller sends 1 via P0.8, that is 8th pin of port 0, so that will pass to the 4th pin of driver. In turn, the output 4, that is the corresponding output of the driver become 0, so which is in turn going to energize the relay. Okay, this is about the pin identification. So we identify 2 pin. The one is 11th pin of port 0 to control the buzzer, and the second one is 8th pin of port 0 to control the relay. Both will act as an output port. That is essentially our microcontroller should send the value through this port. So obviously these 2 ports are output ports. Now let us consider the switch. In this schematic we have a switch. That switch is connected to a terminal called external interrupt. So this switch can be used for both external interrupt as well as to control the devices. So here the switch terminal external interrupt corresponds to connector B. In connector B, the 7th pin is connected to external interrupt. At the microcontroller side, in connector B, the 7th pin corresponds to P2.12, that is 12th pin of port 2. So the 12th pin of port 2 is in turn connected to switch. So whenever the switch is closed, the external interrupt, this terminal will generate logic 0, and whenever the switch is open, essentially this terminal will be 1. So this 12th pin of port 2 acts as an input, means your microcontroller should read the status of the switch. Okay, if this 12th pin of port 2 comes with logic 1, then the switch is open, and if the 12th pin of port 2 is 0 when the microcontroller reads it, then the switch is closed. After identification of the pins, you have to configure them as general purpose input output pin. In order to configure the pin function, you have to use pin selection register. Since these pins corresponds to port 0 and they are within 0 to 15, you have to use pin selection 0 register. The functionality of the pin selection 0 register is explained in the earlier video. So you have to make the corresponding position for 8th pin as well as 11th pin as 0 0, and rest of the bit position should be padded with 1, so that you are ensuring only the 8th pin and 11th pin will altered as general purpose input output pin, and you are not going to affect the functionality of the other pins. The corresponding value is 0x, in hexadecimal it is 0xFF3CFFFF. Here 0x indicates it's a hexadecimal number. So this value is going to AND with the original content of the pin selection 0 register to ensure only the 11th pin and 8th pin is going to altered as general purpose input output pin, whereas rest of the pin functionality doesn't disturb. And this pin selection register 0 comes under pin configuration structure. Once you configured those pins as GPIO pins, you have to set the direction of this pin. Direction means either input or output. Now to set the direction, you have to use FIO DIR register, that is fast input output direction register. Here the pins are 11th pin and 8th pin. The corresponding bit position should be made as 1. If you want to make them as an output port, the corresponding position of the register should be 1. If you want to make them as an input port, the corresponding position should be 0. By default, FIO DIR register will have 0 value. That means by default all the general purpose input output pins are input in nature. If you want to change the direction to an output, then you have to write or you have to pad 1 to the corresponding bit position. Here we are padding for 11th as well as 8th bit position. Therefore, the corresponding hexadecimal value is 0, 0, 0, 0, 0, 9, 0 and 0. And other thing is, you should not disturb the direction of the rest of the pin. Therefore, the rest of the bit position should be padded as 0, and you have to OR this value with the original content of the FIO DAR register. Once the direction of the pins are set, if you want to send logic 1, then you have to use FIO set register. So if you want to switch on the buzzer corresponds to 11th pin of port 0. So if you set the 11th position of port 0, then the corresponding value is 0, 0, 0, 0, 0, 8, 0, 0. If you equate this value to the FIO set register, that ensures that your microcontroller is going to send logic 1 to the 11th pin of port 0. So that's the instruction is LPC underscore GPIO FIO set equals to 0x00000800 ensures that logic 1 is sending via 11th pin of port 0. In turn, it's going to switch on the buzzer. Similarly, if you want to switch off the buzzer, you have to send logic 0. Then you cannot use set register, you have to go for clear register. If you want to send logic 1, then you should use FIO set register, and if you want to send logic 0, you have to use FIO clear register. Okay, so in this case, if you want to send logic 0, then the corresponding bit position should be made it as 1 with the help of FIO clear register. So similarly, if you want to switch off the buzzer, then the register used is FIO clear with the value 000000800, and if you want to switch on the relay corresponds to 8th bit position. Okay, the relay corresponds to 8th bit position. That means this bit should be 1. If you made this bit as 1, then the value is 000000100. Okay, again, by using the set or clear register, you can send either logic 1 or logic 0 via 8th pin. So this is for switch on or switch off of the relay. This is about algorithm of program. Now we'll look into the program. You have to include a header file #include lpc17xx.h, because all the registers what we earlier discussed corresponds to this header file. Then we are initializing the main program. Then you need to mandatorily include two functions before, that means after declaring the variable, you have to declare two functions, that is system initialization and system core clock update. These two are the standard function, corresponds to CMSIS, that is Cortex microcontroller system interface standard. So these two functions is necessary to update the clock value. Then with the help of pin selection 0 register, you are configuring 8th pin and 11th pin as GPIO. So this is a command, it's an instruction. So this pin selection 0 comes under pin configuration structure, and you earlier see the value. So with the help of FIO DAR register, you are setting the direction of 8th pin and 11th pin of port 0 as output port. So this direction register comes under LPC underscore GPIO 0. Since you are changing the 8th pin and 11th pin corresponds to 0th port, so this should comes under the structure LPC underscore GPIO 0. So while 1, this is an infinite loop, and this while loop is used to check the status of the switch. Now since the switch is connected to port 2, that means 12th pin of port 2, we are using a structure LPC underscore GPIO 2, and FIO pin register is used to read the complete status of the port 2. So the complete 32-bit information of port 2 will going to stored in FIO pin register. Now this content is going to ANDed with the value 00001000. This value corresponds to the bit position 12. Okay, since this values corresponds to the 12th port pin. Now whenever the switch is pressed, this 12th pin returns with logic 0 value, and whenever the switch is not pressed, that means whenever the switch is open, this returns with logic 1 value. So this AND logic AND operation returns true value whenever the switch is open, and it returns with false value whenever the switch is closed. Now to invert that, we are using an inverter. So overall while condition become true after including the inverter. Overall while condition become true when you press the switch, and this become false when you open the switch. Okay, so when you press the switch, we need to switch on the buzzer and we need to switch off the relay. That's why we are using the FIO set register. The corresponding value of the 11th pin will be leads to this hexadecimal number. So this will be equate to the set register, and in order to switch off the relay, we are using clear register. With the help of set and clear register, we are switching on the buzzer and relay. These corresponding values are discussed earlier. Similarly, if the switch is open, then the while condition become false, so your program control will comes here. In this case, we are going to switch off the buzzer by using clear register. With the help of set register, we are switching on the relay, and we are including some short span of delay, and after delay we are going to switch off the relay. So here whenever you are not pressed the switch, then the relay will be toggling between on state and off state for a short duration of time, so that you can observe the blinking of LED which is connected to the relay. This is about the program flow, and you can watch the demonstration video at the end of this